Okay. Um, Thank you everyone for joining this section. So in this section, we'll be discussing section 2.3, which talks about linear functions and slope. So we begin by talking about the slope. So when we talk about the slope, um, so the slope of a line that passes through the distinct points x1, y1, and x2, y2 is giving us um, is giving us um, changing the y, changing y, and divided by the change in the x. And this is also described as a rise um, divided by the run, and in it's also giving us y2 minus y1 divided by x2 minus x1, where x2 minus x1 is not equal to 0. All right, so this is the formula for finding the slope. And so we can continue with one example where we look at how to find the slope. So example 1. Example 1 is determine the slope of the line that passes through the point. Slope of the line that passes through the point for -2 and -1 and 5. All right, so slope m is equal to y2 minus y1 divided by x2 minus x1. And so this equals to 5 minus -2 divided by -1 minus -4. And so this gives us -7 divided by 4. So this is the slope of the line that passes through this point. There are two ways of representing the equation of a line. We have the point slope form, point slope form. And we also have the slope intercept form. All right, so we're going to begin with the point slope form way to represent the equation of a straight line, and afterwards we'll look at the slope intercept form. All right, so the point slope form the point slope form of the equation of a line. All right, so the point slope form of the equation of a line, equation of a non-vertical line with slope m that passes through the point x1, y1 is given by y minus y1 is equal to mx minus x1. So the point slope form of an equation of a non-vertical line with slope m that passes through the point x1, y1 is given by y1 minus y2 is equal to x minus x1. So let's take an example. So in this example, um, let's call this example 2a. And in this example, it says um, write an equation in point slope form. So it says write an equation in point slope form for the line with slope slope 6 that passes through the points passes through the point 2, 5, then solve the equation for y. All right, so let's find the using the point slope form, the equation of the line that passes through the points 2, -5, and it has a slope of 6. So that by the point slope form, we have y minus the y point, which is -5, and this is equal to m. M is 6, and times x minus x1. X1 here is 2. So this is x. So this is y1. This is x1, and this is y1. And our 6 is our m. All right, so y minus 5 becomes y plus 5 is equal to 6 times x, which is 6x, minus 6 times -2, which is 12. And so if we subtract 5 on both sides, then we'll have y is equal to 6x minus 12 minus 5 equals to 6x minus 17. So this gives us the equation of the line that we are looking for. Let's look at one more example on this. Example 2b. Let's look at a similar example on this. So example 2b. Example 2b says the um, write the point slope form of the equation satisfying the given conditions. All right, before we come to example 2b, let's look at the slope. Let's look at the slope-intercept form first. Let's look at the slope-intercept form first before we come to example 2b. Let's look at the slope-intercept form first before we come to example 2b. All right. All right. Before we come to example 2b, let's look at um, the slope-intercept form first. Okay, so let's look at the slope-intercept form. The slope-intercept form of the equation of a line. So the slope-intercept form of an equation of a non-vertical line with slope m and y-intercept b is y is equal to mx plus b. So the slope-intercept form of an equation of a line with slope m and y-intercept b is given by this. All right. Let's look at this example 2b, which is so. Let's look at example 2b. Example 2b, which says write the point slope write the point slope um, write the point slope write the point slope form of the line satisfying the given conditions. Then use point slope form. Then use the point slope form of the point slope form of the equation to write the slope intercept form. Intercept form of the equation passing through the points -8, 0, and 0, 8. All right, so the slope is equal to y2 minus y1 divided by x2 minus x1. So that is equal to 8 minus 0 divided by 0 minus negative 8. And this is 8 divided by 8, which is equal to 1. All right, so the slope is equal to 1, and the point slope formula is y minus y1 is equal to mx minus x1. And so we know that, so we can pick any of the pair of points. The pair of points that we've been given are minus 8, 0, and 0, 8. So we can pick any of these to represent um, x1, y1. Any of these pair of points would work. So we can pick this as our x1 and pick 8 as our y1. And so we substitute this into the equation, and we know we just found out that the slope m is equal to 1. M is equal to 1. So we can substitute this into the formula. So that will give us y minus y1, which is y minus y minus y1, which is 8. Y minus y1, which is 8, is equal to m, which is 1, times our x minus our x1, which is 0. So this becomes y minus 8 is equal to x. And so if we add 8 on both sides, we'll have y is equal to x plus 8 as the equation. And this is in the point slope form. This equation is in point slope form. In the point slope form, remember, is y is equal to mx plus b. So this is our b. What is in front of the x, which we don't write, is 1. It's our m, and this is our x. So this equation is in the point slope form. All right, let's look at an example of how to graph, let's look at an example of how to graph an equation using the slope-intercept form. So let's look at this example here. So this will be our example 3. This should be our example 3. And it says graph the function f of x is equal to 3 over 5x plus 1. And so the steps that we're going to follow in graphing this is first to plot the y-intercept, which will be the point 0b, which in this case is the y-intercept is 1, so the point 0, 1. B here is 1. If you compare this to y is equal to mx plus b. Our y-intercept b is 1 here. All right, and the next thing is we are going to use, from the slope, we're going to do rise over run to trace the point. So let me write that down, from the slope, we're going to determine, the points. We're going to determine the point rise over run starting from the y-intercept. We determine the point rise over run starting from the y-intercept. All right, so let's try to draw this line. Um, all right, so the y-intercept, let me get the point. So this is 1, 2, 3. So the y-intercept is the point 0, 1. So the y-intercept is here. And so after we have the y-intercept, the next thing is to trace the rise. Remember the slope is m is equal to 3 over 5, and the slope is equal to the rise over the run. So from this y-intercept form, we trace the rise 3 points up. So 3 points from 1 takes us to 4. Unless we do a run of 5. So run of 5 from 0 here will take us to this point. So we have these 2 points here. So this is the rise of 3, and this should be a run of 5. So we have these 2 points, and with these 2 points, we can draw a straight line through these 2 points. And so this will be the equation of the line or the function y is equal to 3 over 5x plus 1. All right. Okay, so let's look at the equation of a horizontal line. Okay, so a horizontal line is given by an equation of the form y is equal to b, where this b is the y-intercept. Where b is the y-intercept of the line, where b is the y-intercept of the line, and the slope is 0. Where b is the y-intercept of the line, and the slope is 0. All right, so let's pick an example where we graph um, a horizontal line. So this will be our example 4. And it says graphing, graph the horizontal line y equals to 3. All right, so to graph this horizontal line, we're going to pick a pair of x points. We'll find the corresponding y point will always be the same. So we can pick x points from -2, -1, 0, 1, and 2. And the y point will always be 3. It doesn't change. All right, so we can plot this pair of points on the graph as so. So we can plot these pair of points on the graph um, as so. So this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Oh, this is negative. So this is -1, -1, -2, -3, -4, -5. Just -1, -2, -3, -4, -5. This is 1, 2, 3, 4, 5. All right, so the points that we have are for -2. For -2, we have for -2, the y is always 3, so -2 and 3 is about this point. -1, the y is still 3, so it's about this point. 0 and 3, 1 and 3, and 2 and 3. All right, so our horizontal line is a line such as this, and this is the line of y equals to 3. So this is how we graph a horizontal line. Let's look at the equation of a vertical line. The equation of a vertical line. All right, so a vertical line is given by the equation of the form x is equal to a, where a is the x-intercept. Where a is the x-intercept, and also for vertical lines, they do not have a slope, so the slope is undefined. The slope of the vertical line is undefined, right? So we know that m slope is equal to y2 minus y1 divided by x2 minus x1. So if you have a vertical line, such as, let's say this is -2, this will be a line x is equal to -2. If you have a vertical line, the value of the if you have a vertical line, the value of the x points do not change. So along this line, at every point along this line, the x is always -2. So that means if you want to find the slope, you're going to have m is equal to y2 minus y1 divided by the x2 minus x1, which is 0. Because the x coordinate on this vertical line does not change, x2 minus x1, the difference between x2 minus x1 is equal to 0. So you have a division by 0. That is what gives us the undefined, that is what gives us the undefined value for the slope of a vertical line. And for the horizontal line also, we said the slope is equal to 0. So for the horizontal line, let's say this is 2, this is the line y is equal to 2. We said the slope is 0. because also m is equal to y2 minus y1 divided by x2 minus x1. But for the horizontal line, y2 minus y1 is always 0. There is no change in the value of y. So y2 minus y1 is always 0. So y2 minus y1 is always 0. So you have m is equal to 0 divided by x2 minus x1, which gives the slope of the horizontal line as always equal to 0. All right. All right, so let's look at this example 3, this example 3b. Let's look at example 3b. Um, okay, let's look at this example here, which is for 3b. So example 3b, it says, let me write it down. It says find the value of y. Find the value of y if the line through the two given points through the two given points is to have the indicator slope so we have the points are minus 3y and minus 5 2, and the slope m is equal to negative 2. All right, so we know that m is equal to y2 minus y1 divided by x2 minus x1. And so the slope m is 2, so m is negative 2, so negative 2 is equal to y2, y2. So these points are x1 and x2. So y2 is this point here, x2 is this point, y1 is this point, and x1 is this point. All right, so this is equal to y2, which is 2 minus y1, which is y, divided by x2, which is negative 5, minus x1, which is negative 3. So this is equal to 2 minus y divided by minus 5 plus 3. So this equals to 2 minus y divided by negative 2. All right, so we have negative 2 is equal to 2 minus y divided by negative 2. If we multiply negative 2 on both sides, multiply negative 2 on both sides, this negative 2 cancels out this negative 2. So what we have is negative 2 times negative 2, which is 4. What we have is 4 is equal to 2 minus y. And so if we subtract 2 on both sides, then we have negative y is equal to 4 minus 2, which equals to 2. And now we divide both sides by negative 1. And so we have y is equal to negative 2. So this is how we get y is equal to negative 2. All right. So let's look at the next thing on our list, which is the general form of an equation of a straight line. So let's look at the general form of the equation of a line. The general form of the equation of a line. So every line can be written in the general form ax plus by plus c is equal to 0, where a, b, c are real numbers, and a and b cannot both be 0. A and b cannot both be 0. All right, so let's use an example to example to illustrate the general form of an equation of a line. So this is example 5. And it says find the slope. Find the slope and the find the slope and the y-intercept of the line whose equation is 3x plus 6y minus 12 is equal to 0. All right, so to find the slope and the y-intercept of an equation which is given in the general form, this is in the general form. We will have to rewrite this general form in the point slope form. We'll have to rewrite this in the point slope form to retrieve our slope, which is m, and our y-intercept, which is b. All right, so for this, we can first subtract 6. We can first subtract 3x on both sides. So that will give us 6y minus 12 is equal to negative 3x. And we can also add 12 on both sides, and that will give us 6y is equal to minus 3x plus 12. And we can divide through by 6. So that will give us y is equal to negative 1/2 x plus 12 divided by 6, which is 2. So from here, our slope is minus 1/2, and our y-intercept is 2. Our y-intercept is 2. All right, so let's look at another example. So this would be example 6. And this will be about graphing using intercepts. Example 6 is graph using intercepts, graph using intercepts, and the equation is given in the general form as 3x minus 2y minus 6 is equal to 0. And so this is the find x-intercept. So the steps that we are going to take in graphing this line is first of all to find the x-intercept. Is to find the x-intercept. And to find the x-intercept, we substitute 0 for the value of y. So that will be 3x minus 2 times 0 minus 6 is equal to 0, which implies 3x. If we add 6 on both sides, 3x is equal to 6, and we divide both sides by 3. So that will mean x is equal to 2. So the x-intercept is 2. So that means we have the pair of points y is 0, x is 2, and y is 0. And the next thing is we find the y-intercept. So to find the y-intercept, we set x is equal to 0. And to find the x-intercept, we set y to be equal to 0. So if we set x is to be equal to 0, then we have 3 times x, so 3 times 0 minus 2y minus 6 is equal to 0. So if we add 6 on both sides, we have minus 2y is equal to 6. We divide both sides by negative 2. So we have y is equal to 6 divided by 2, which is negative 3. All right, so we have the second pair of points, x is 0 and y is negative 3. So we have these 2 points as the x-intercept points, y-intercept points, and now we can graph the function using these 2 pair of points. So let's do that. So let's do that. So let's do that. So let's put our points in 1, 2, 3, 4, 5. This is negative 1, negative 2, negative 3, negative 4, negative 5. This is negative 1, negative 2, negative 3, negative 4, negative 5. This is 1, 2, 3, 4, 5. All right, so our first pair of points for the x-intercept is 2, 0. So 2, 0 is this point, and our other one is the y-intercept is negative 3. So negative 3 is this point. So we have these 2 pair of points that we can draw a straight line through. So this will be the line for 3x minus 2y minus 6 is equal to 0. So that is how we graph using the intercepts. Okay, so lastly, let's look at an application problem, an application question. Let's look at an application question. And it says, so this will be our example 7. And it says use data points. Example 7, it says use data points. Use data points 3, 1, 7, and 57.04 and 354 and 354 and 57.64 to obtain a linear function. Linear function that models average global temperature, average global temperature, f of x, average global temperature, f of x, for an atmospheric carbon dioxide concentration, atmospheric carbon dioxide concentration. So carbon dioxide concentration of X parts per million. And round M to 3 decimal places. And B, the y-intercept to 1 decimal place. All right, so we are given a pair of points. We are asked to find a linear function that models a function for um, average global temperature. All right, so the first thing is we have to find the slope, which is m is equal to y2 minus y1 divided by x2 minus x1. So this is equal to uh, 57.64 minus 57.04 divided by 354 minus 317 is equal to 0, is equal to 0 points, is equal to 0.6 divided by 37 and rounded to 3 decimal places. This is about 0.016. All right, so we have the slope at 0.016, so we can use the slope-intercept formula. We can use the slope-intercept formula, which is y minus y1 is equal to mx minus x1. And we pick any of the points as y1 and x1. So if we pick the second pair of points, we'll have y minus y1, which is 57.64, is equal to the slope, which is 0.016 times x minus x1, which is 354. All right, so y minus 57 0.64 is equal to 0.016x and times 0.016x times 354 is 5.664. All right, so we now have to add 57.64 on both sides, and we have 0.016x minus 5.664 plus 57.64. And so this gives us y is equal to 0.016x plus 52. So this becomes our f of x. The function that models global average temperature. All right. So this is where we're going to end for today, and we are going to continue the next section 2.4 in the next video.